Okay, this is my history of math research project, and for my topic, I chose the history of women in calculus. Okay, now first, what is calculus? Calculus is a brand of mathematics that studies how things change, like the rate of change, areas under a curve, all sorts of different things. Calculus is used in many other forms of education and research, such as science, engineering, economics, medicines, and many more fields. Historically, though, calculus is a male dominated field, but women have found their ways to make important contributions that are often overlooked by most people. And then the purpose of my presentation is to highlight key women, their work, and the challenges that they faced to achieve what they did. Okay, here are some barriers that women face. So, first, they were denied access to universities and academic positions, so they really couldn't learn calculus, they couldn't teach it, they couldn't understand it, so this made them hard for them to access it. And then social norms often discouraged women from pursuing math. They thought it was more just like a male-dominated field and that women should stick to something else. However, many women found a way to get around these norms by publishing under a fake or anonymous name so that people wouldn't know what gender they were. Usually they pose as like a male name. Despite all these challenges, though, women made major advances in calculus and other math fields. Okay, now I have some famous math figures. The first one is Emily du Châtelet, and she was a French mathematician, physicist, and an author during the Enlightenment era, and she's best known for her French translation of calculus and her commentary on Isaac Newton's Principle of Mathematics, which remains the standard French edition today. Her commentary for Isaac Newton included explanations and expansions on Newton's use and ideas of calculus, particularly in mechanics and motion. She also improved upon Newton's concept of kinetic energy using calculus-based reasoning to argue that energy is propositional to the square velocity, which anticipated later developments in physics. Okay, now for another one, we have Mary Somerville, and she was a Scottish mathematician, and she was also self-taught, and she overcame gender barriers to become one of the most respected scientific and mathematic writers of her time. She translated and expanded Laplace's Mécanique Céleste, making calculus and celestial mechanics understandable to a broader English audience, and she also published a book, Mechanisms of the Heavens, which became a standard university text in Britain for decades, and she also worked on theoretical math involving differential and integral calculus in astronomy and electromagnetism. Okay, next one we have Sofia Kovalevskaya, and she was a Russian mathematician, and she was the first woman in modern Europe to hold a PhD, and she faced significant gender obstacles, and she even had to enter officious marriage to study abroad. She pioneered work in partial differential equations, a key component of calculus and mathematical physics. She developed a solution to the Kovalevskaya top, one of the few known exact solutions to a spinning rigid body, and she used advanced calculus and analytical mechanics to achieve this. Okay, and for my final famous figure, we have Grace Chisholm Young, and she was the first woman to earn a doctorate's degree in any field from Göttingen, and she co-authored extensive research and educational material in calculus, and she worked independently on the theory of functions, limits, and derivatives, which are core concepts within calculus that we learned a lot this year, actually. Okay, and then progress made within the 20th century, so more women began to enter math fields as universities were now accepting them. Some examples were Julia Robinson, and she worked on fundamental problems using logic and calculus foundations, and then the other one was Mary Cartwright, and she applied calculus and differential equations to a chaos theory. And then women began leading departments and publishing independently, and they didn't have to publish anonymously or under a fake male name. Now we have women today in calculus, and women's contribution to calculus research, applications, and educations have significantly shifted the way that we have learned calculus. And then we have some examples: Ingrid, don't know how to say her last name, and Karen Uhenbeck, and they both applied calculus to many different processes and educations that they went on to use in their field. There were many organizations created to help support women in STEM, such as Women in Math, Girls Who Code, and other sorts of organizations. And that's my presentation, and here are my sources.